Okay, so here's how you solve exponential functions. When you have an exponential equation like this, you want to change your base of 32 and your base of 2 to the same number. So we're going to rewrite 32 as 2 to the 5th equals 2 to the 3x minus 1. And now because those are the same base of 2, we can just set the exponents equal to each other and solve for x. So 5 equals 3x minus 1, solve for x. So that's how we're going to start today's unit with exponential equations. Number 1, solve the exponential equation. 3 raised to the 2x minus 1. We're just going to leave it like that. 3 raised to the 2x minus 1. The 1/9 needs to be rewritten as a base of 3. So 3 to the something should give you 1/9. If you do 3 squared, that would be 9. So therefore, we want to do 3 raised to the negative 2 because that would give you 1/9. Since, like I just said, 3 squared is 9, and therefore 3 raised to the negative 2 would be 1/9. If that didn't make sense, you can write this as 1 over 3 squared. And that's 3 to the negative 2. Not that the bases are both the same of 3, you can just set the exponents equal to each other. 2x minus 1 equals negative 2. Solve for x. 2x equals negative 1. If I make a mistake, someone stop me. So number 1, done. So those are the kind of questions you'll start seeing on your next unit called exponential functions. Number 2, you have 0.25. So think of the 0.25 as 1/4. So 1/4 raised to the x. You have an 8 raised to the x plus 2. And then you have a 16 raised to the 2x minus 3. We need to rewrite all those bases to the same number, like a prime number, like 2, 3, 5. So I'm going to rewrite 1/4 as 2 to the negative 2. Again, because 1/4 should be 1 over 2 squared. And then I can just do 2 raised to the negative 2. That's equal to 1/4. Times, let's rewrite 8 as 2 to the 3rd. Because that's 8. X plus 2. And finally, 16 should be written as 2 to the 4th. Because that's 16. Now you want to simplify everything. Don't cancel the bases yet because you can only set the exponents equal to each other once you have one base on the left side and one base on the right side of the equal sign. Right now we have a base of 2 here and another base of 2 there, so we're going to have to combine them into one single base first. Then we can set the exponents equal to each other. So first let me simplify this by getting rid of all these parentheses. That's 2 raised to the negative 2x times 2 raised to the 3x plus 6. Make sure you distribute 3 times 2 as well. And then 2 raised to the 8x minus 12. Now, one more step before we cancel those bases. These, the left side here needs to be combined into one single base of 2. So we need to combine those into one single base by adding the exponent, because that's the rules of exponents. When you multiply, you're supposed to add exponents. Negative 2x plus 3x plus 6 equals the other side. Okay. Finally, now we have a base of 2, and then we have the other base of 2, and now since there's just one base on the left side and one base on the right side that are the same, we can set the exponents equal to each other. X plus 6 equals 8x minus 12. Now just solve for x. 18/7. That looks right. we can do one more for practice. Example 3. Rewrite everything to a base of 6. So 6 to the first times 6 to the 1/3. The cube root of 6 can be written as a fractional exponent of 1/3 equals 6 squared. Now we need to combine all the bases into one single base before you move on. So here, let's combine those two bases into one single base of 6 by adding the exponents. So 1 plus 1/3, probably 4/3. So 6 to the 4/3 equals 6 to the 2x. Now we can just set the exponents equal to each other. Equals 2x divided by 2. I'll pause for questions, and then we'll move on to the graphing. Okay, so you're going to practice solving those exponential equations. And now we're going to learn how to graph those exponential equations. I guess here's some examples of exponential functions. If you have f of x equals b raised to the x, b is a base that is more than 1, so like 2, 3, 4. Your graph is called an exponential growth, and it looks like this. Call it growth. And just because it's growing as x increases, your function is growing. Next, if you have a function f of x equals b to the x, where your base is positive still, but between 0 and 1, not including 0 or 1. So like if you have a fraction like 1/2 raised to the x or 1/4 raised to the x, your graph is going to look like this, and that's called a decay, because your graph is getting smaller and smaller, smaller as x increases. So growth, decay. Now we need to know how to graph these functions. So here's the general transformations. We will have f of x equals a times b, which is the base, raised to lowercase b, x minus c plus d. A, B, C, and D are all the transformations that can be applied to the function. And like always, A and D are going to be vertical transformations. B and C are going to be horizontal transformations. The last thing I forgot to mention about these functions is that they have asymptotes. They have horizontal asymptotes. Horizontal asymptote. So the ones I just showed you right here is just y equals to 0, because it was just b to the x. But when you start transforming and shifting your functions and you start adding like a plus d or a minus d, that's going to be your asymptote. So now let's learn a little bit more about these exponential functions so that we can start graphing them for real. These are the most common exponential functions that we're going to use in our quiz. They're going to be y equals 2 to the x, y equals e to the x, and y equals 3 to the x. But technically it can be anything. It can be like y equals 5 to the x or 4 to the x. But the ones that I use mainly are 2 to the x, e to the x, and 3 to the x. So let's talk about 2 to the x. First of all, notice how they all look the same. They're not all exactly the same, but they look very similar. So let's start with 2 to the x. If your function is y equals 2 to the x, this is the information that you want to know about it. The domain is all real numbers. The range is going to be from 0 to infinity, but not including 0 because that's an asymptote. The graph has no x-intercept because it can't touch the y equals 0 line. The y-intercept would be when x is 0, y is equal to 1. And I'll show you the table in a minute. And then, like I said, the asymptote is y equals 0. This graph is, I guess it's a growth function, but we call it increasing. So you need to know increasing or decreasing. This graph is increasing because as x gets larger and larger and larger, your y value is going towards positive infinity. So that's called increasing. Finally, the last thing you need to know about this function 2 to the x, you need to know the parent points. So you need to know when x is 0, 1, and 2. So let's do it. If x is 0, you would have 2 raised to the 0 power. That's 1. And that's why the y-intercept is 0, 1. Next, if x is 1, you would have 2 raised to the first power. That's just 2. And then finally, if x is 2, you would have 2 raised to the second power. That's 4. These are the parent points. You need to know how to, I guess you need to know these parent points so that you can apply transformations to it. Either memorize them or just plug in the x. It was pretty simple. Okay, that's what you need to know about 2 to the x. Let's skip e to the x and let's do 3 to the x next. 3 to the x, the info is all the same. The domain is all real numbers because it's always all real numbers for exponential graphs. The range is 0 to infinity because the asymptote is still y equals to 0. Everything else the same. It's still increasing because the graph is going towards positive infinity as x increases. And let's do a little table. The table, honestly, you only really need 2 points on the graph, but right now I'm doing 3. But technically, we only need like 0 and 1, that's it. So if x is 0, 3 to the 0 is 1. If x is 1, 3 to the 1 is 3. And if x is 2, 3 squared is 9. So those are the points that we're going to use. Finally, I guess let's do the e to the x. Very similar. It's still an exponential graph. Domain is all real numbers. The range is 0 to infinity because the asymptote is still y equals 0. It's still increasing because it's going towards positive infinity. And now here's what you need to know about the table. Okay, so 0, 1, and 2. If x is 0, oh, first of all, let me tell you what e is. So e is just an irrational number, like pi is just an irrational number that we use in math. So e is about 2.7. You're going to have to memorize that. So again, it's just an irrational number that the mathematicians made up with for exponential functions. I think it's used like in interest rates. But it's just an irrational number, 2.7, dot, 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 dot. It never ends, but we're just going to go with 2.7. So let's go with e raised to the 0 power is going to be 1 because anything raised to the 0 is going to be 1. E raised to the first power, that's going to be e. And like I just said, you have to just memorize 2.7. And then that's it. We're not going to care about the x equals 2. We only really need 2 points on the graph. But if you look at my answer key, e squared is about 7.4. You just need to remember 2.7, that's it. So now, those are called exponential functions. Now what we're going to do is on the back of the notes, we're actually going to graph transformations on all of these exponential functions. So I guess let's start with the first one on the back. Example 1. Okay, so we're going to graph y equals negative 3 to the x. There's 2 ways to graph this. Number 1, you can make your own table of values and pick your own x's and pick your own y's so that you can graph this. We only really need 2 points, so you can just start picking like x equals 0, x equals 1, and plug it in here. So negative 3 to the 0 is going to be negative 1. Negative 3 to the first is going to be negative 3. So that's one way to graph these. Now you just graph that. The asymptote is going to still be y equals 0 because the graph doesn't have a vertical shift. It doesn't have that plus d anymore, or it doesn't have it, so it's y equals 0. Next, I guess when we do example 3, the graph finally has a shift, minus 3, so that means that the asymptote will be shifted down to y equals negative 3. We'll get there. Okay, so number 1, we can just graph those dots. The asymptote is y equals 0. The domain is going to be all real numbers. Now, let's graph it so we can figure out the range. 0, negative 1. 1, negative 3. If I were to do one more dot, which you're only required to do 2, but if I do one more, because this one's easy, it would be negative 3 to the second, which is negative 9. So let's just do it. The graph looks like this. And then on the other side, it gets closer and closer to y equals 0. So there goes your first ever exponential function. It's basically just that y equals 3 to the x, but it's been reflected over the x-axis. So I just took this and reflected it over the x-axis. So that's why these y values became negative. Negative 1, negative 3, negative 9. The domain should be all real numbers for all exponential graphs. The range for this specific one is now y is less than 0 because the graph is going from negative infinity up to 0. You could write this in interval notation if you prefer. The x-intercept is none because it never crossed the x-axis. The y-intercept is 0, negative 1. And now to tell if it's increasing or decreasing, you look at the graph and you, I guess, look at it from left to right. As x gets larger and larger, your graph is going towards negative infinity. That's called decreasing. Because the y values are getting more and more negative, negative infinity. And that's how you do number 1. Okay, number 2 is going to be the same way. Maybe I'll just make you a table and then you graph. But number 2, again, you can just make your own table. And this time let's just pick 2 x values, so 0 and 1. 2 raised to the negative 0 is still just 1. 2 raised to the negative 1, it's going to be a fraction. 1/2. Okay, let me do just one more. 2 raised to the negative 2 is 1/4. So when I graph this function, it's going to be, let me show you, it's going to be this parent, the 2 to the x, but this time it's been reflected over the y-axis because we have a negative x. The b is negative, so reflected over the y-axis. So it's just going to look this way. Let's graph it. 0, 1. 1, 1/2. 2, 4. So it's going this way. The asymptote is still y equals 0. And on this side, okay, on this side, it's going to have some points where they're 1,2. So if x is negative 1, y would be 2. Okay, that's all we need. So it's going to be going that way. You can answer the information here by yourself about the domain, range, intercepts. I want to do the increasing or decreasing though. So in this graph, as x gets larger and larger, the y values, what they're doing is they're decreasing. But this time they're getting closer and closer to 0, but they're still decreasing. They're getting smaller and smaller and smaller towards 0. So this would still be called a decreasing function. Your job is to finish the rest of this. Look at the answer key online. Okay, now let me show you how I personally graph these. So number 3. On example 3, again, one way of graphing this is you can make your own table of values and start plugging in like x equals 0, y equals 1 if you want. So you can start plugging in here x equals 0. You can start plugging in x equals 1 and find your own answers. That's one way. Or, that's not what I do though, but that's what you can do if you want. Okay, what I do to graph all of these is I use the parent function. So the parent function is 2 to the x. So y equals 2 to the x. Okay, so I know the parent function is y equals 2 to the x because that is the base. So then I know that on the parent, if x equals 0, y equals 1. On the parent, if x equals 1, y equals 2. So that's what I know. Then what I do is, to graph this function, I just apply the transformations. So for example, the only transformations here are vertical stretch by 3 and vertical shift down 3. So my x values didn't change. There was no horizontal transformations. The y values did change by stretching them 3 times y and then shifting them down 3. So that's what I like to do. And I apply the transformations to the parent. So again, x didn't change. It's still 0 and 1. Y would be 3 times y minus 3, and I'm just going to look at these y values. So I'm going to do 3 times 1 minus 3, so 0. Then I'm going to do 3 times 2 minus 3. That's 3. Which is the same thing that you would have gotten over here if you made your own table of values and plugged in x equals 0 here, and then plugged in x equals 1 here. You would have gotten this table. So you pick your favorite, whatever you like. Now when I graph this, I like to graph the asymptote first. My asymptote has been shifted down 3 because of the vertical shift. Right here. So the graphs have been shifted down 3. And the only other transformation is that it's been vertically stretched by 3, so it's going to look the little stretch. So let's graph it. 0, 0. 1, 3. You can put 3 dots if you want to. I'm just going to go with 2. So the graph is going to go that way. And so on the right side, the graph is going to go towards infinity. On the left half, the graph is going to go towards the asymptote, y equals negative 3. The domain of all exponential graphs is always all real numbers because x can be anything. The range depends on the function, but this range would be from negative 3 to infinity. The intercepts, well, you can see on the graph that the intercept is 0, 0 for both the x and the y. And finally, the increasing or decreasing, as x is getting larger, the graph is definitely going towards infinity, so that's increasing. And that is how I graph exponential functions. Now we're going to practice a couple more. I guess we can practice example 4. Okay. Example 4. You can graph example 4 by making your own table of values and plug in your own x and, I guess, your own x. So you can plug in x equals 0 here, figure out what y would be. And then you can plug in x equals 1, figure out what y would be. What I like to do is I like to do the parent point. This parent graph is still a base of 2, so it would still be 2 to the x. So the parent would still be 0, 1, 0, comma 1, and 1, comma 2 for the parent. But now I'm going to apply some transformations. Because there's a negative in front of the base, that's a vertical reflection. So So reflection over the x-axis. And because there's a +1, that's another vertical shift. So here I'm going to put negative y plus 1. Because we need to take the parent points, which are 1 and 2, multiply them by a negative and add 1 to them. For the x transformations, although it says x plus 4, that c value is a negative 4. So x plus 4 means you shifted to the left 4. So I'm going to do x minus 4 and shift them to the left 4. So again, I'm going to use these parent points right here. X is 0 and 1, so I'm going to subtract 4 from them. 0 minus 4, negative 4. 1 minus 4, negative 3. So those are the points that I'm going to be graphing. Next, for the parent points on the y values, we need to multiply them by a negative 1 and add 1 to them because of these transformations. So negative times 1 plus 1, 0. Negative times, nope, that's not right. No, that's right. If I'm doing it wrong, someone help me. Okay, the next one is 2. So negative times 2 plus 1. Negative 1. Okay, that looks right. So then, so these are the points that I'm going to graph and graph the asymptote. My asymptote, y equals 1, because it's been shifted up 1. Graph those points. Negative 4, 0. That's the x-intercept. Negative 3, negative 1. That's all I need. You can put a third point if you want to, as I did on the answer key, but this is just going to go this way. So to the right, the graph is just going to keep going towards negative infinity. And then to the left, it's going to be going that way. So I know the graph is going down towards negative infinity because there's a reflection over the x-axis. So you would just take like the parent and then shift a reflector over the x-axis. Domain, all real numbers. Range, y is less than 1. X-intercept, it was clearly negative 4, 0. Now, I guess if you couldn't see your x-intercept because you didn't graph the same point that I graphed, then the way you would find your x-intercept is you would have to plug in 0 for y here and solve for x. And there's a way to figure that out, and you would still get the x-intercept as negative 4, 0. The y-intercept, well, I can't tell from the graph because I didn't choose x equals 0. I guess if you chose x equals 0, you should already know the y-intercept. So let me plug in 0 in for x. This would be negative 2 to the 4th plus negative 16 plus 1, negative 15. And since no one says anything, let me check the answer key. That looks right, 0, negative 15. Finally, the graph is decreasing because as x gets larger and larger towards the right, the y values are going towards negative infinity. Decreasing. Okay, let me skip this one. You can just do it by yourself, make your own table, or use the parent points. This time use the parent points of 3 to the x. And then this being raised to a 2x, that's a horizontal compression by a half. Horizontal compression by half. So multiply your x values by a half if you're going to use my method. If not, just make your own table of values. Let's definitely do example 6. So example 6 involves that e thing. Okay, this is where it's going to help using my method of doing things, so using the parent points, because if you don't, then there's no way to do this without the calculator. And this is all non-calculator. So one more time, here's how I do my method of graphing these. First, I make a table of values of the parent function. The parent for this would be e to the x, because that is the base. So here's the parent. Let's make the parent points, or just copy them from over here, because we already have them. So the parent points would be 0, 1, and 1, comma 2.7. So 0, 1, 1, and then about 2.7. So we only need 2 dots. That's about. So those are the parent points. Now what we're going to do is we're going to apply some transformations to them. The horizontal transformation should be to the left 1, because although it says x plus 1, that is to the left 1. So we're going to do x minus 1 here. So let's take these x values and subtract 1. 0 minus 1, negative 1. 1 minus 1, 0. Now let's do the y value transformations. That one is just a minus 2, so y minus 2. So we're going to do 1 minus 2, negative 1. 2.7 minus 2, about 0.7. And those are the 2 points that I want to graph with the asymptote. The asymptote is y equals negative 2. And now let's just graph negative 1, negative 1. 0, comma 0.7-ish. About right there. You should have 2 points on the graph. Somehow on my answer you only have 1, but that's not right. I mean, that's not good. You need to have at least 2. So the graph would look like this, just like the parent function, because it wasn't reflected anywhere. It was just shifted down and to the left. So it should look like the parent, like this, but shifted down and to the left. Domain, all real numbers. Range, from negative 2 to infinity, or just put more than negative, y is greater than negative 2. The x-intercept, I don't know, but it looks like 0, 0, but it's not 0, 0. The way you would find an x-intercept is you need to plug in 0 for y and solve for x. Let me see if I can do this. Plug in 0 for y. Oh yeah, we're definitely not going to be able to do that. We can't do it right now. If I try to solve for x here, I'm going to move the minus 2 over, so 2 equals e to the x plus 1. Okay, so at this point, you can't really solve for the x-intercept yet, because the only way to solve this 2 equals e to the x plus 1 is to use something called logarithms, and that's going to be our next lesson. So I guess after I teach you logs, you come back and solve for x-intercept for sure, definitely before the quiz. But I'll just give you the preview right now. The answer for this is going to be, the way you would solve it is to take the natural log. Again, that's called logs. So natural log of 2 equals, a natural log will cancel with the e, x plus 1. So then my x-intercept, if I were to write it down, it would be ln of 2 minus the 1. So come back once you learn logs, definitely before your next quiz. The y-intercept should be easy. It should just be when x is 0. So when x is 0, we know the approximate y-intercept is 0.7, but let's write it exactly. So if x is 0, you would have e to the first minus 2. That's the exact y-intercept. E minus 2, which is about 0.7. The graph is increasing. And now you got to practice this. Okay, I think I have like 2 minutes. I can squeeze in one of these down here where you're just trying to do the same thing by just sketching a graph, but you need to practice this. There's a homework worksheet for practice. And remember, you can just wait till the weekend to do this after you study for your test. But practice graphing these and finding all the info. Let me squeeze one of these. This one. It says to do this without graphing, but we're still going to just go ahead and sketch it. So, number 7, y equals 1/3 raised to the x minus 2 plus 11. The first thing that I'm going to do to this thing is I'm going to rewrite it because I don't like a fraction of 1/3. So this thing is the same thing as y equals 3 raised to the negative 1, x minus 2 plus 11. So again, I don't like a base of 1/3 just because it's a fraction and I don't know those parent points. So I'm going to rewrite the 1/3 as 3 to the negative 1 because that is 1/3. So then if I distribute the negative, here's my function. Y equals 3. So the negative parentheses x minus 2. Let me not even distribute it. I'm just going to write it. Negative parentheses x minus 2. Now I'm ready to try to sketch this and find domain, range, intercepts, and everything. This function, if you remember the parent is y equals 3 to the x. Whoops. The parent looks like this. It's increasing with the y equals to 0 asymptote. This specific function now has been shifted up 11. So now y is equal to 11 is your new asymptote. And then the only other thing that happened to this is the negative right here in front of the x. That's a reflection over the y-axis. So instead of your graph going up like that, it's actually going to be going down like this. I mean, it's still positive, but it's decreasing now. Maybe it helps if I draw like an x and y axis here. So it's going like that. So you can enter the info right here. Domain, all real numbers, always. Range is going to be from 11 to positive infinity. Intercepts, plug in 0 for x. No. Y-intercept, plug in 0 for x, solve for y. X-intercept, plug in 0 for y, solve for x once you learn logs. Finally, the graph is decreasing because it is getting closer and closer to the y equals 11, and that's called decreasing. Okay, so if you wanted to see the rest of today's examples, here's the video. One thing I noticed about example 7, when it came to the x-intercept, I know we're supposed to wait until we learn about logs, but based on the graph, okay, here's the graph. Based on the sketch of this graph, since the graph was shifted up to y equals 11, it would clearly never cross the x-axis, so that has no x-intercept. That's why it's helpful to just sketch the graph. So let's try example 2 the same way. Example 2, let me make a sketch of the graph first. So my function is, the parent should be 2 to the x, which is this looking parent graph here. But because there's a plus 10, that means the graph has been shifted up to y equals 10. So let's shift it. And then also because there's a negative in front of the base, that means that your graph was reflected over the x-axis. So instead of being at the top here, it's going to be going down. So my graph, if I'm just sketching it, it's going to look like that. So that is the sketch for example 8. And now I can answer a lot of questions about domain, range, and intercepts. Domain, all real numbers, like always. Range is going to be from negative infinity to that 10. We can just put y is less than 10. x-intercept. Okay, this time there is an x-intercept, which I'm going to have to find, but I'm going to wait until we learn about logs to get to this x-intercept. For now, I'll give you the answer, but once you learn how to solve logs, come back and just make sure you know how to find these x-intercepts. But for now, I guess if you look at my answer key, it shows you the work, but this x-intercept is going to be log base 2 of 10 minus 1. That's the x-intercept. So come back once you learn about logs. Y-intercept is when x is 0, so if you plug in 0 here, you should be able to get a y-intercept of probably 8? Negative 2 plus 10, so 8. And finally, the graph is going towards negative infinity, so it is decreasing. And that's how I work out these questions. We can do it again on number 9. Just sketch a picture first, and then try to find the info. So, number 9. Again, it helps if you sketch a picture. This time the function is e to the x, which all the parents look like that. And the only transformations here, I guess, that matter, it's going to be shifted down 8, and then to the left 2, but that's not going to affect your graph. So let me shift it down 8. Right there. Then there was no reflections anywhere, so your graph is still going to go up towards infinity and towards this asymptote. So that's the sketch of the graph. Domain is all real numbers. The range for this one looks like negative 8 to infinity. The x-intercept, again, you would have to plug in 0 for y and use logs to solve for x. So for this one, I'm just going to give it to you now. Natural log of 8 minus 2. Come back and fix it. Or come back and actually solve it once you learn logs later this week. The y-intercept is when x is 0. I'm going to leave it in terms of e because I'm going to have e to the 0 plus 2, so e squared minus 8. We can just leave it in terms of e. And finally, the graph is going to infinity, positive infinity, so it's increasing. And now make sure you finish the rest of these examples, look at the answer key, and then do your homework worksheet.